The traditional engineering weed-out class, calculus. Calculus. C-A-L-C-U-L-U-S. Calculus. What is calculus? My students asked me the other day, and that's a good conversation starter. Calculus happens to be one of the very first or early math classes that engineers should study in college. And unfortunately, it's viewed as this horrible thing, and it might get a reputation of being so hard. I think it's because a lot of times it's not taught very well, and so students don't pass it, and then they have a really hard time with it, thinking that they're just not meant to study math or calculus or not meant to study engineering, and it's really unfortunate. There's whole studies about how it's a weed-out class, and there's also more educational research about how calculus can be taught without all this stigma, and people can succeed with calculus if it's taught in better ways. But I digress. Let's talk about what calculus is. It is a math class. It is the study of, in my view, how things change. And so you can take really complicated problems that are sometimes difficult to study without calculus, and you can use calculus to break down that complicated problem into a bunch of tiny, simpler problems, which then help you get the solution. So an example that you might think of is the simple problem could be, hey, I'm driving at 30 miles per hour for 3 hours. How far did I travel? If you know your basic math, you might realize, hey, you multiply your speed times your time, the 30 miles per hour times 3 hours, and I traveled 90 miles. Boom. Done. What's complicated is, in reality, I am a really crazy driver and I'm traveling at 70 miles per hour on the highway because I feel like it, even though the speed limit is 60. And then I see a really fancy car that I want to chase. So I start chasing it at 100 miles an hour and I accelerate all the way up. And then the cops catch me and like I'm trying to escape them. So I accelerated up to 130 miles per hour. Don't do that. And then I need to narrowly escape hitting another truck. So I slam on the brakes and it decelerates down to like 30 miles an hour and I spin out and my speed is erratic, going up to 50 and back down to 0 and I stop. That is not a smooth speed, and if you were to graph my speed over time, it would be up and up and down, and it's a really weird looking non-linear curve. How far did I travel? You can't just multiply speed times time in this case, because like let's say I was traveling like a madman for 3 hours, you aren't going to multiply 3 times 30 anymore. You could ballpark it by multiplying by my estimated average time, but hey, that's ballparking. That's not exact. How far exactly did I travel when I was driving like a madman on the highway? Well, calculus is all about figuring this out. All you do is you split up that big problem into a bunch of little ones. You figure out how far did I travel over 1 second? Well, over 1 second, I was traveling for, 60 miles an hour. And then for the next second, I was traveling at maybe 62 miles an hour. And for the next second, I was traveling at 70 miles an hour. And for the next second, I was traveling at 100 miles an hour somehow. And so on. You break it up into these little time steps is what we might say, or these little windows of time. And you figure out how far did I travel in that little tiny window. And calculus helps us figure that out. You broke down this complicated, curvy math problem into a bunch of little tiny ones that are easier to solve. And I will, in the end, just add up how far I traveled in those little 1 second windows of time, and that gives me my answer. That's what calculus is. You take these complicated problems and break them up into these little tinier problems and smush the solutions together. And it'll help us find out the area under a complicated shape. It'll help us figure out, how far I've traveled, or maybe it'll help me figure out my speed if I have a complicated movement pattern. It's for all sorts of analyses of complicated, changing situations. And it takes work to figure out, just like writing A 30-page paper is that much harder than writing a 2-page paper. And in English, what do they teach you? They teach you when you write something really long, break it down into smaller chunks. That's kind of what calculus is. We take these more complicated problems and we break it down into smaller chunks and figure those out. And it's totally doable, just like writing a 30-page paper is doable. It just takes more work. And engineers, you can learn it. Don't be discouraged. You just have to stick it out. And honestly, if you are better at visualizing situations, it totally helps out. That's my one practical tip. If you're the type of person who naturally, made and designed your own clothes, or you sculpt a lot, or you play a lot of 3D video games, those types of people might have a slight advantage in learning calculus because you're already visualizing a lot. But if you're not that type of person, maybe you should start doing a lot of that. Just try to apply math or measurements to physical things. And that has been shown to help people learn calculus. So anyway, that's what calculus is. That's my spiel on it. It is the engineering word of the day. Hey, this is Pius saying thank you once again for listening to the Engineering Word of the Day podcast. If you like all this education talk, you might want to listen to my education podcast, the K-12 Engineering Education Podcast, and you can find it at k12engineering.net. That's the website, or you can find it wherever you listen to your podcasts. Thanks.